Okay. Um, Welcome back, I guess. Today we're looking at lesson 33, which is applying counting principles. So our warm-up, the first piece, our vocab of the day, the middle number in an ordered list of numbers is called the blank. Okay, so that piece right there would be the median. If we were going to find the mean, remember that's where we would add all of those up and divide by 4 because we have 4 different data points. So we got 30 plus 20 is 50, plus 20 is 70, plus 12 is 82, divide by 4, and that doesn't go in there, so we get 20.5. And then if we were finding the median, everything is almost in order, but not quite because we have that 40 that needs to go to the outside. So we get 10, 20, 30, 32, 38, and then 40. And then we have our middle two is 30 and 32, so that means our median would be 31. We can either add those up and divide by 2 or just realize that 31 is between both of those values. So yeah, talking about counting principles today. Our first new piece in counting theory, an experiment is any process that results in one or more outcomes. If a process is repeated one or more times, each time it is performed is sometimes called a trial, and the experiment consists of all the trials. That's something you guys have probably done in your science classes and everything like that, so that's probably not too new, but it might be new to you for math class. Also, this piece isn't very new, using a tree diagram. So a cafeteria offers turkey, ham, and chicken salad sandwiches. The choices for those, or the bread choices, are rye and wheat. How many different sandwiches can be ordered? So if we're going to make a tree diagram, we can have, maybe this is our you getting lunch. So you're saying you either want turkey, ham, or chicken salad. We don't have a last choice there. And then our bread for each of those would be either rye or wheat. So those pieces at the very end, that would be our total possible outcomes. We could do that. We could also flip it around and do the bread first if we wanted to. So we could say rye and wheat, then off of each of those we would have turkey, ham, or chicken salad, turkey, ham, or chicken salad. So you can see on both of those we have 6 outcomes, so you could do it either way. You could flip those around and you'll get the same answer. Make sure you get this vocab in your notes. Make sure when you are going through these you have notes in front of you, or you are taking notes off of this. So first thing, a sample space, set of all possible outcomes. An event would be any subset of a sample space. The addition counting principle, that would be counting the different outcomes that we have. And then mutually exclusive would be events in the sample space with no outcomes in common. Okay, so that'll go a little bit into our next piece here. So this is using the addition counting principle. So remember that it's just adding. So you're given a situation we can either draw an ace or a face card at random from a standard deck. So realize that there's 4 aces, and then there could be a king, queen, or jack of any of the 4 different suits of cards. So that would be 12. So we have a total of 16 possible outcomes out of that standard deck, which is 52. So we would have 16 out of 52 in this case. Okay, and then that second one, choose a prime number or a multiple of 6 or a multiple of 10 by choosing a number at random from the set of whole numbers 1 through 20. So prime numbers, we would have 2, 3, 5, 7, 11, 13, 17, and then 19. Multiples of 6, 6, 12, 18. And then multiples of 10 would just be the 10 and the 20. So you can see with all of these, nothing overlaps. So all of these things would be mutually exclusive if you were to break those into 3 different sets. So prime numbers, multiples of 6, and multiples of 10 are all mutually exclusive because we don't share any outcomes between them. Like we don't have number 12 in 2 different categories. So our possible outcomes would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 out of 1 through 20. That's 20 possible outcomes. And that top one, we could simplify that down to 8 over 26 or 4 over 13 as well. Okay. Now if we are using multiplication, using the fundamental counting principle. So in this case, a student is choosing a 3-letter password for email. So if letters may be repeated, that would be, we have a 3-letter password, so we think of it like this. So we have 3 different spaces and we're multiplying them together. So we just have to ask ourselves, how many letters are there in our alphabet? 26. And if they can be repeated, that means that that number isn't changing. So we have 26 possible letters. Second, we would have 26 possible letters and then another 26 possible letters. So that would be 26 to the 3rd power, which equals a big number. Let's look at the next scenario if they wouldn't be able to be repeated. So again, we would still have 3 outcomes, but it would just be 26. And then if now one of those numbers or letters is used up, so then we'd be down to 25 and then to 24. So you'd multiply those 3 things together to get your answer. Okay, and then independent and dependent variables, or just independent and dependent, something that we've talked about for a really long time. Independent just means that things aren't affected by one another. Dependent meaning that they do, one outcome would affect the other. So let's say we have letters A through E written on 5 index cards. A card is chosen at random, then another card is chosen to determine whether the events in each case are independent or dependent. So we have choose A and then choose B. If the first card is replaced before the second is chosen, so that part right there is crucial, because if something is replaced, that means that everything goes back into the deck. That would make this independent because we have just as many opportunities as we had from the first. And then choose A and then choose B if the first card is not replaced before the second card is chosen. So that would be like we have 2, 3, 4, 5 possible outcomes. We could either get A, B, C, D, or E. And then we chose A, then that's not replaced, so now we only have B, C, D, and E left over, so that would be dependent. So you can see how that affects the next turn because we have one less card. Almost finished here. So this is kind of like our passwords problem. So there are 6 positions in volleyball: left front, center front, right front, left back, center back, and right back. So how many ways can 6 players be placed into 6 positions? So again, we just have to think of it in the fact that we have 6 different positions. So if we put a player in left front, out of those 6, or there's 6 possible outcomes of players that we could put in left front. After that, 1 player is used up. They're already in a position, so we have 1 less. So you can see that just gets less and less with each space that's filled, down to the last one where it would just 1. This would be the same as 6 factorial. Factorial is this exclamation mark, which just means you are multiplying by each. It looks exactly like this. You're multiplying by 1 less than each of the number all the way down to 1. So if we want to figure that out, we have 6 times 5 is 30, times 4 is 120, times 3 is 360, times 2 is 720, times 1 is still 720. So we have 720 possibilities. If we have 6 girls in a volleyball team with those 6 positions. Okay, here is your homework. Hope you have a great day.